In this artificial intelligence class, we will see another important topic from third unit, that is information extraction. That will come under NLP, right? So in this information extraction class, we will see what is information extraction and the 6 different approaches of information extraction, like the finite state automata and probabilistic model, conditional random fields, and ontology extraction, and automated template construction, and machine reading. What is information extraction? So it is a process of acquiring knowledge by scanning text and looking for occurrence of particular class of objects and the relationship among objects. So this is called as information extraction. That is, by scanning a text, we try to get some knowledge from the text. Okay. For example, suppose we want to extract instance of addresses from web page. Okay. For getting the address, the database field required are the street, city, state, and zip code. So these are the field we required to get address, right? When come to second example, suppose the storm of weather report. We want the storm of weather report. For this, the required field are the temperature, wind speed, and rainfall, right? So by this way, from the given information, we need to get some knowledge. Okay. So this is called as information extraction. If the domain is very limited, then the accuracy will be very high. Okay, knowledge accuracy will be very high. But if the domain is more general domain, okay, then we required some more complicated learning technique to get the knowledge, right? This system uses more complex models, which includes limited notation of syntax and semantics, okay, in the form of templates. Why? Because the complexity will get increased day by day, that is deterministic to stochastic, domain specific to general, and small scale to large scales. That is, the domain got increased day by day, hence the system uses more complex model with limited notation of syntax and semantics, right? The 6 different approaches in information extraction. First one is finite state automata for information extraction, and second one probabilistic model for information extraction, and third one conditional random field for information extraction, and fourth one ontology extraction from large corpora, and fifth one automated template construction, and sixth one is machine reading. Let us see all those things one by one. Finite state automata for information extraction. Before this, let us try to understand the attribute based extraction, because this is the simplest one. This attribute based extraction, it assumes the entire text refers to a single object, okay, and the extraction means it will extract the attribute of the object, okay, it extracts the attributes of object. For example, so this is the given text, IBM ThinkBook 970 with the price $399. Okay, this is the set of attributes. From this we try to extract the attribute. What are the attribute? IBM means manufacturer, the model is ThinkBook 970, and price is $399. Okay, so these are the attributes. So here we have to define a template for each attribute to extract. Okay, for each attribute we have to define a template. So we can use this template for extracting any like the objects. Okay, any similar object we can use the same attribute. The finite state automation, which is used to define the template for each attribute to be extracted. Okay, and from this finite state automata, the regular expression is the simplest one, and it is having 3 parts for defining the attribute. First one is prefix, target, and postfix. Okay, let us see one example for defining the price in dollar by using regular expression. Okay, here the prefix is price. Price is prefix and the target regex. So here we have to display the numeric value. If it is a single digit, we can give likewise. So the numbers 0 to 9 will be printed here. If we include plus sign followed by digit, means one or more digit will be displayed here. Okay, suppose point followed by 2 digit means, so the period followed by 2 digit, and the question mark means if there is a digit that will display, otherwise nothing. Okay, so finally this is our format. Okay, dollar followed by one or more digit and point followed by 2 digit. Okay, if 2 digits are there, that will display. If there is no digit, that won't display. For that purpose we have used this question mark. Okay, and postfix is nothing, that will be empty. Okay, so this is how we have to give format for all the attributes. A relational extraction. A relational extraction system which deals with multiple objects and relations among them. That is, from the given input plain text, it identifies the object and it will find the relation between the objects also, right? And it can be built with a series of cascaded finite state transducers which consist of a series of small efficient FSA, that is finite state automata. Here each automation receives a text as input and the input data will be translated into different format, and this different format will be passed to next automation. Okay, so this is called as cascaded finite state transducers. Let us see one example for this relational extraction system. First one is input the given story. Okay, the text will be given to our relational extraction system. Okay, and the plain text, this is our plain text, and this will be given to our system as input. So here the objects are highlighted in different color. Okay, so after finding the object, we have to create the or identify the relationship among the object by using given verb. Okay, so after identifying all those things, that is after extracting all those things, the text will be translated into logical expression format. Okay, the given text will be changed, that is converted into logical expression format, and this logical expression format will be given to the next step, next iteration. A typical relational based extraction system is fastest. This fastest consists of 5 stages. First one is tokenization, complex word handling, basic group handling, complex phrase handling, and structure merging. Okay, so we will see all these 5 stages one by one. The first one is tokenization. Tokenization means segments the stream of character into tokens. That is, from the given sentence of character, that will be divided into words, numbers, and punctuations. Okay, so a small word is called as token, and this tokenization can also implemented in HTML, HTML, and XML. And second one is complex word handling. Complex word means more than one logical entities will be there, and this will be identified by using finite state grammar rules. Okay, see, this is a single name and this may be a complex word. Okay, that is more than one lexical entities are there. The third one is basic group handling. When come to basic groups, there are 4 groups are there. First one is noun group NG, verb group VG, and these two are most important group, basic groups. And the third one is proposition PP, and the fourth one is conjunction CJ. So these 4 are the basic groups. Here the given text will be chunked into these groups into unit. Okay, and the units will be merged into here. This is the given input string, and this input string will be divided into the sequence of tagged group. Okay, so as per our example we are having 17 tagged group. Here we can see all the groups: noun group, verb group, proposition and the conjunction. Okay, according to this the given string will be converted into different subgroups. The fourth stage is complex phrase handling, that is the basic groups will be combined to form these complex phrases. For example, the given rule company plus setup joint venture of with company plus and followed by question mark. Okay, so it captures how to describe the formation of joint venture. So joint venture here, the joint venture will be displayed in which format, that will be described here. The last stage is structure merging. This will come from the previous step, that is merging the complex phrases. Okay, merging the complex phrases is called as structure merging. So the given sentence, the joint venture will start production in January. Okay, here there are two references to this joint venture. Okay, and they should be merged into one. Okay, so this will start production is one reference. In January, when it will start production in January, this is another one. So everything should be merged into one single sentences, and this is an instance of identity uncertainty problem. The advantages and drawbacks of finite state template based information extraction. First let us see the advantages. These systems will be very much suitable for the restricted domains. If the domain is very specific, then the system will work well. In this domain, it is possible to predetermine what subject will be discussed and how they will be mentioned. If it is possible, then the system will work very well. And when come to the cascaded transducer model, it is very much helpful for modularizing necessary knowledge and easing construction of systems. Okay, if the system is very simple, then we can easily use this, and this system will be very much suitable for reverse engineering text. And next let us see the drawbacks. And this system is not suitable for generalized domain. If it is specific domain we can use, but when come to generalized domain the system will not be used, and it is less successful at extracting information in highly variable format. That is, if the format is written by human and if more number of subjects included, then this is less successful, and it is not suitable for noisy text or varied input text, and it is too hard to get all rules and their priorities. Okay, right, priorities, which rule will come first, which rule will come next, or defining is very hard, and in those situation we can use the probabilistic model instead of using this rule based model. The probabilistic model for information extraction. The simplest probabilistic model is hidden Markov model, which is otherwise called as HMM. In HMM there are two stages. First, it will identify a sequence of hidden states which is represented by xt and the corresponding observation, that is ET, at each step. And the observations are, that is ET, observations are the words of text and the hidden states. So these to be observed, and when come to hidden state, it may be a target or prefix or postfix part of attribute template. Okay, otherwise in the background that may be not part of the template. Okay, so these are the hidden states. Let us see one example for this. The given text, there will be a seminar by Andrew McCallum on Friday. Okay, this is the given text, and the path for the text. Okay, two HMMs are trained here. First one trained to recognize the speaker and second one trained to recognize the date. Okay, this is the second one, and the hyphen are here. Those are used to indicate the background state. This diagram explains the hidden Markov model for speaker of talk announcement. Okay, here we are having prefix, target and postfix. Target symbol is square, that is two square states are there and these are the target. Okay, when come to the second target, there is a self loop, that means the string can be any length, matching string can be any length, that represented by self loop. And when come to prefix, four circles are there and in the postfix only one circle is there in the right hand side. Okay, and for each state only a few of high probability words are shown here in this diagram. In this model there are two approaches. First one is apply each attribute HMM separately, and second one is combine all the individual attributes into one big HMM. The conditional random fields for information extraction. Here the discriminative model, which is used to understand the text as well as the conditional probability of hidden attributes of the given text. Okay, that is, this model first understand the text as well as the hidden probability, that is the hidden attributes of the given text. Okay, it will understand the hidden attributes of the given text. Okay, the given text will be represented as E of 1 to n, E1 to n, and the conditional model, this particular model will finds the hidden state sequence, that is capital X1 to n. Okay, that maximize the probability of capital X1 to n such that E of 1 to n, that is E of 1 to n is the given text, and from the given text the hidden states will be extracted. Okay, n number of states extracted, that is hidden states. Hidden states will be extracted and the hidden states will be dependent to each other, that is xt, that is any of the hidden state that will be dependent on x1, right. And the model is conditional random field, which is otherwise called as CRF, which models the conditional probability distribution of target variables given set of observed variables. Okay, so we have to find the target variable from the observed variables. Okay, so the discriminative model, that is used to understand this text as well as the hidden attributes of the given text. Here the CRF that represent many different structures of dependencies among the variables. That means the hidden data are dependent to each other. In what way those data will be dependent, in what structure is maintaining here, everything will be represented by this CRF. Okay, and from this one common structure is linear chain conditional random field. Okay, so this represent the Markov dependencies among variables. Okay, the Markov dependencies among variables. The Markov dependencies is actually available in temporal sequence. So this is one of the temporal model, learning model. Okay, this will represent the dependencies between the variables, how the variables will be dependent to each other, and the predicted target is an entire state sequence rather than a single binary variable. Okay, so the target is the entire state sequence. So here E1 to n is observations that may be a Word document, and x1 to n be a sequence of hidden states. As we already seen, E is a given text and x1 to n is hidden state. Okay, the hidden state, for example, it may be prefix, target and postfix states. Okay, those are hidden states. Here the linear chain conditional random field which defines the conditional probability distribution, that defines the conditional probability distribution, that is the probability of x1 to n such that e1 to n which is equal to alpha e power of summation of I equal to 1 to n capital F of x I minus 1 x I e I. Okay. So, this is the conditional probability distribution. Here alpha, so this alpha is nothing but normalization factor and f is nothing but, this f is future function. Okay. So, this defines the weighted sum of the collection of k components future functions. Okay. So, here this particular future function, the same here, that will be represented as the summation of k lambda k f k of x I minus 1 x I e I. Ontology extraction from large corpora. It is a open ended, that is the ontology extraction is open ended and it gets information from all type of domains. Okay, this ontology extraction is not dependent on particular specific domain, but it can accept information from all type of domain. With these large domains, that is huge volume of text, this extract dominated by precisions, that is the accuracy will be very high and exactly like question answering on the web. That means for a particular question it will give exact answer. Likewise the ontology extraction the output will be very specific or very accurately, and the result, that is the output can be statistical aggregated gathered from multiple sources, okay, rather than extracted from one specific text. Okay, the result will be statistically aggregated gathered from multiple sources. This is important. Learning an ontology of concept categories and subcategories from large corpus. Okay. So, the learning will be taken place by concept categories and the subcategories of concept from very large volume of text. Okay. The text size may be 100 million pages. Okay. This can be possible only in the ontology, and the work concentrated on templates, that is generating templates, and the template should be very general and this suitable for almost all the domains, not for a particular specific domain. Okay, and it has high precision, that is the always, this should be always correct, that means almost always correct when they match. Okay, if the concept will be mapped, then the template will be always suitable for everything. And the most productive template, this is the common template, this can be suitable for all the domains, that is noun phrase such as noun phrase open parenthesis comma np close parenthesis star open comma close question mark and within bracket and or np question mark. Here the bold words and commas, the bold words and commas must appear in the text itself. Okay. And the parentheses are used to grouping the text, and asterisk, this one asterisk means the repetition of 0 or more number of times the same character, and the question mark means optional. Okay, this may be present or not present, and the noun phrase, okay, np means noun phrase is a variable standing for noun phrase. NP means noun phrase. This template can be matches any domain text. Okay, that means a disease such as rabies affects your dog. Okay, such as is a keyword which can used in this sentence, and another sentence supports network protocol such as DNS. Okay, so here we are using such as. By using such as, see, such as is the keyword which can used here. Okay, and or are optional here, right? So the first text concludes rabies is a disease, and second one concludes DNS is a network protocol. Okay, so the similar templates can be constructed with the keywords including, especially, and or other. Okay, by using these keywords also we can construct more number of such sentences. Here is another template. Noun phrase is a noun phrase. NP is an NP. Okay, here is a keyword. Okay, by using this we can generate she is a beautiful girl, he is a rich boy. Okay, sometimes it is a subcategory relation. It denotes only the subcategory relation. And with large corpus we can use only a high precision template. That high precision template means which we have used in the previous slide. Okay, and sometimes we will miss many statements of subcategory relations. Suppose if we use this high precision template, we can miss some subcategory relationship. Automated template constructions, that is the template will be constructed automatically, right? The subcategory relation is very fundamental one, and to learn this some of the template will be very much helpful to identify the instance of occurrence in the natural language text, right? And it is possible to learn template from few examples. Suppose if we give few example, from this example the system will learn the template, and by using this template the system will generate more such examples. From those example it will again learn the template. Okay, so likewise the system will automatically generate the template. Here we are having 5 examples. So if we observe these 5 examples, we can easily understand that this is author title relation, author and title of the book. Okay, author and title of the book relation. But when come to learning the system does not know any knowledge about the author or titles. The above given words are used to search on the internet, and this will give 199 matches, and each match will give the tuple of 7 strings. The 7 strings are author, title, order, prefix, middle, postfix and URL. Here order is nothing but which will come first. If order is true means author will come first. If order is false means the title will come first. Okay, this is called as order. And second one is middle. Middle is nothing but the characters between author and title. Okay, that is called as middle. And prefix means the 10 characters before the match, that is prefix. Suffix means 10 characters after the match, and URL is nothing but the web address where the match was made. Okay. The simple template generation scheme which can find the templates to explain the matches. Okay, here the language of templates that is designed to have a close mapping to match themselves and to automated learning and to emphasize high precision. Okay, and here the each template has same 7 components that matches. The 7 components we have already seen: author, title, order, prefix, middle, postfix and URL. The very big drawback of this particular approach is sensitivity to noise. Okay, if there is any noise, then there is a problem to generate the template automatically. That is, if the first few template is incorrect, then error can propagate quickly. Okay, to overcome this problem, first one, not to accept new examples unless this example will be verified by multiple times. This is the first approach. And second one, not accept the new template unless it discovers multiple examples. So the template should discover multiple examples, then only it will be accepted, and this also found by other templates. Okay, so by using these two approaches we can easily overcome this weakness. Machine reading. Machine reading means a system that can read by its own and it can build its own database. Okay, this is called as machine reading, and these systems are relation independent systems. That is, it can work on any relation. Okay, there is no dependent on the relationship, and this system can work on all relations in parallel. This is important because the IO demand of very large corpora, right, and the system like traditional information extraction system, that is targeted a few relations and uh, more like a human reader. How we are reading? By reading the text we can learn something, isn't it? Likewise, the system also read and it can understand something from the text, hence this field is called as machine reading. The most popular machine reading system is text runner. This text runner uses code training to boost its performance. Okay, but this needs some taxonomy of 8 very general syntactic templates. Okay, so 8 syntactic templates are given here in this example, and this template could cover 95% of ways that relationship are expressed in English, right? So the templates are given here. From the given set of labeled example, the text runner trains linear chain conditional random field, that is CRF, to extract further examples from unlabeled text. Okay, so by using this labeled example, it tries to extract further example from unlabeled text, right? And the features in CRF which includes the words like to, of, the. Okay, and it never include nouns and verbs. Okay, because the text runner is domain independent, so it cannot rely on the predefined list of nouns and verbs, right? So far we have seen the information extraction, that is IE, from third unit, that is natural language processing, and we have seen 6 approaches of information extraction. The first one is finite-state automata, probabilistic model, and conditional random field for information extraction, ontology extraction from large corpora, automata template construction, and machine reading. And you can expect any one of the 5 mark or 10 mark question from this topic, and for more information please go through your textbook. Thank you.